Alright. Wow. That was a lot of stuff at once. Okay. Okay. Well, turn this down. That was a lot to process. Okay, so here's the plan. Alright, we're gonna. You can't see it yet, but you will. We're gonna be doing my AP Calc Final live on stream. Oh, that's not what I want to do. Lord. There we go. I can shrink this more. There we go. Okay. So we're gonna make it work. How and why I don't know, but we are. So here, let's start swapping. Okay. I don't know. Oh, do I press this? Oh! Whoa. Okay, I'm still learning how to do stuff. Okay, fine. Okay, let's get started. Actually, no, I do have to, like, can I crop? No, that's not what we want. I can zoom in, though. Okay, that might work. Hold on. I'm making this work to where it's, like, safe. I'll just go with that. Okay. Little slides. Sure. I'm gonna put this up. Y'all can't see what I'm doing. That'd be illegal. Oh yeah, this one. Who's texting me? Oh, clown's back. Okay, anyways. Let's make a blank presentation. How's that look? That basically is about what I'm doing pretty much. Okay. You can see the gist of it, and that's what matters. Okay, so I'm gonna make it like really corny. So AP Calc Ulus AB no AB fi Finals. Ugh, I'm adding a space. Like, yep, I'm doxing myself. Great. That's fine. We're making it like as plain as humanly possible. But first, we actually have to go to YouTube. Have to, we're also going to look at my math notes. Whoa, it's my stream. Okay, here are all the papers. Um, dude, really? Chat, would have been great if I had a camera on right now. This man comes in through the door. I'm gonna have to do this real quick. This man came in through the door and threw a soft taco from Taco Bell at me. And now all the cheese is everywhere. God, thanks. Okay. So I gotta like surgically remove everything. God. Okay. Let's see how this works. Well, I'm having to open up the keyboard later. Great. Okay, that's besides the point, though. We have food, apparently. Even though I ate like 4 pieces of pizza earlier. Don't mind the ASMR. Okay, so here's what we're gonna look up. I don't share this, okay. Can we get like a Khan Academy video? Okay, sure.
Hello, calculus kids. This is Mr. Bean. Today's lesson, we're going to talk about optimization. We're going to get into the very beginnings of what this is, how it works. I'm really excited because this is a hard lesson.
Okay. So what I have to do for the final, and I can probably get out the I'll get out a couple of things. Well, first, we'll get out the lesson. So there it is. And then we'll get out the criteria. If I can reach into my bag correctly. Okay, here it is. I can get rid of all of my econ stuff because I don't need it anymore. I'm pretty sure I passed the class with like a B. Which is great, by the way. Solids. Solid, okay. Here it is. Optimization project. I need these two, and then everything else can go to hell. Okay. So, I must optimize a 3-dimensional container. That's it. No, the container must be in the shape of a cylinder, aka a can, a square prism, or something different such as a cone or sphere. Your container should only have 2 measurements, such as a radius and height, or a square-based prism, i.e. you only want to have 2 variables. So, like, length, width, and height, pretty much. This project must be done in teams of 3, 2, or individually. Since I am sad, we're doing it individually. You can either choose to maximize the container's volume, keeping the surface area constant, or minimize its surface area, keeping the volume constant. Alright. That doesn't sound so bad. If I actually remembered how to optimize. You must use an actual container, empty as fine. Measure its dimensions, and use those dimensions to calculate its surface area and volume. Do not use the volume specified on the packaging. So the project must include a colorful poster or slideshow containing a photograph or drawing of the actual container listing its dimensions, calculations of the container's surface area and volume, all of your work including the primary and secondary constraint equations, derivative of your primary equation, then optimize dimensions and how you determined them. Number line analysis to show the dimensions result in an optimized solution. Graph of what you optimized, volume or surface area in terms of the radius marking the optimized value. Okay. Basically, we have to optimize my mailbox. And what do I mean by that? Well, I'm gonna upload this to Discord and I'll just do it that way. So, what I mean by this, I will bring in Discord now. But, who am I sending this to? Prime? Okay. We're optimizing this box. The Transformers Legacy Evolution Core Class Optimus Prime Bumblebee 2-pack. As the box, we are optimizing. It has length, width, and height, and I need a measuring tape or something for this. So, fun times. Like, can I squeeze this in here? Yeah, I'm gonna move the audio mixer actually. There we go. So we're gonna go over the notes. It would be a lot easier if I could like show myself with like a webcam or something. I can't. So here's what we need, pretty much. So the general approach to solving optimization problems is to determine what quantity is being maximized / to minimize, also known as optimized. Draw a picture, define a variable, or use a formula to identify quantities not given. Write an equation that can represent the quantity being optimized. If the equation contains more than one variable, another equation with the same variables will be needed in order to isolate a variable to show the relationship. Substitute the results of the second equation into the original equation if necessary, then differentiate and find the max / min with the derivative equal to 0. That makes sense. What if I just found a Rubik's Cube, dude? No, we'll use this box. I'm gonna go, we're gonna go back to the slideshow. We're gonna go find a little measuring tape. I'll be back. Okay. Thanks to my father, he is going to get a measuring tape right now. So, we're going to basically follow. Actually, hold on. Let me. Where is. Okay. We're gonna read the prompt again. Maximize the container's volume or minimize its surface area. Where's my phone? I gotta text Ray about this. Okay.
When that one friend that gets no girls starts kissing a middle-aged woman who has twins. When that one friend that gets no girls starts kissing a middle-aged.
Alright, chat. Here's our cheat code. Start with a square-based prism. That's it. We did the dimensions of Optimus Prime's, like, left window pack. That'd be funny. Wish time. Yay. Okay, I'm gonna, like, do that. Okay. So, what did I optimize? I'm gonna sue. Max volume. Did you find one? Alright, we're gonna be at a problem. You know, there's one place I know would probably have what I'm looking for. Yeah, I'll go look over there real quick. We're gonna be right get back, and I know, but I need a measuring tape, and he's got one. So I'm gonna go grab it real quick. I'll be back. I okay. So we got our measuring tape. I think. Okay, so is that 10? We'll go with 7.5 and 2.25. Okay, hold on, I'm gonna write this down wherever they are. Okay, here. So, oh Lord, if this pen is out, I'm gonna cry. Okay. Box. Actually, no. We're not gonna write it down. We're gonna type it down. Okay. Box dimensions. Okay. The width. Okay, now we're gonna start with length equals. Going that way, so 10. Width equals 2.25, and height equals 7.5. This is all in inches. This is where I'm gonna sue someone. Okay. And then the formula for volume is length times width times height. Which I'm not. Can I like make cursive or something? Is that a thing? I don't want to use Pacifico though. I don't want to use lobster either. I guess Pacifico will work. Length times width times height. Actually, no, Pacifico works perfectly. Dude, if I could get a webcam working up, I'd have one by now. I have like 2 and neither of them work. I'm probably gonna go bully my brother Andy for one. 49 more people. Yeah, no, you're gonna need a max of 50 people, and I want like actual evidence. If you try hard enough, you could probably get people to sign it. I'm gonna do it like this. Okay. That's where my 70 alternative accounts come in. I would do it. Hold on, child, I'm gonna sneeze. Nope, never mind, it went away. Okay, we need to go over an example problem, so we're gonna do that right now. I'm gonna make another slide. Okay. So I'm gonna actually show you guys now what we're doing. Alright. So we're back in the world of living. Here's what we're doing, alright? So that's not what we're doing. Hold on. Alright, so these are our measurements. Right? So our box length, alright, width, and height. And it's all just a box, so you got like... Alright, so this is our box. Alright. So this is our box. We want to maximize volume. Do we really? Because I'm not taking the surface area of the whole thing. How do we minimize surface area? Hold on. Rectangular piece of cardboard. Oh, what? Wait a minute, hold on. I'm looking at some of these. This is, this is very questionable. Okay. Here, let's go back to that YouTube video and let's
Okay, I know that sounds
study.
awful, but the reason I like it is because it is a little bit challenging. It helps our minds expand a bit, and it has some real-world applications. A lot of times we'll talk about things in mathematics, like where the heck would we use this? This optimization stuff is used all over the place. In fact, it's funny because I was a business major for a while in college.
Shut up.
Couldn't leave out because there were so many things that were going on with this optimization for businesses. First, let's make sure we understand the word optimize. Optimize, thanks to Google, thank you Google, to make the best or most effective use of a situation or a resource.
Okay. To make the best or most efficient or effective use of a situation or resource. That, I don't think we care about that.
In the context that we're going to be using it, we're going to try to optimize something to make, for instance, the most amount of money, or the
most amount of money.
amount of material. Something that has a maximum or a minimum. If we see that in a word problem where we're trying to find the most or the least,
Can we like get a box
that
now?
is an optimization problem. That's what variables, x and y, in terms of one variable, I should say. So I want to say the difference of the two y values. This is actually just a play on the Pythagorean
I want a
theorem.
box.
because this,
Hey, we have a box.
and this is what cardboard is. If you got this, Kelly, let's make a box.
Okay. Here's the problem, chat. Miss Kelly needs. Actually, you know, I'm gonna do this like right now on the side. We're gonna save this box. We're gonna come here. We're gonna make another box, or we're just gonna do this ourselves. Okay. So my crap is gonna be in like whatever shade of blue this is. All right. So Miss Kelly, oh, that's Mr. Kelly. I forget what Mac's last name. Okay, whatever. You know what? Mrs. Kelly. We're just gonna say Miss Kelly because my choir teacher's Miss Kelly. She's great. Miss Kelly needs to make an open box, top box, store all her magic cards. She has a piece of cardboard that is 14 by 30 squared. Okay, I kind of get where we're going with this. So let's go.
He's got a box that we're going to work with some cardboard.
Yeah.
And I can't even remember. I don't think I gave you this much room. Sorry, you might have to draw that a little bit smaller. So we have a cardboard piece of paper that we're cutting out squares in the corners here. So let's cut out a square there and here. So just do that in all four corners. And
Maybe we don't even. Hold on, chat. Wait, hold on. Maybe we don't even do a box at all. Board dimensions. Because maybe we could just do this. A square then. Chat, we're going to maximize a rhombus. No, I hate a rhombus, like, actually. Hold on, no. What? For what? Okay. A rectangle is not a square, but a square is a rectangle. A rectangle is defined by length times width, has 4 sides, with the sides opposite of each other being parallel, and forming 4 right angles. Who cares about geometry anyways? Brother, I hate geometry. Trigonometry is where it's at. Like, I had so much fun learning about trig. For, like, no reason either. It was kind of funny. Actually, wait, hold on. How flat was the image I made? Or I got? Oh, wait, okay, so we can still use the same thing, kind of. So, hold on. We want Pacifico, okay. God, never mind. We'd want length, or just length, parentheses, L, close parentheses, equals 10 inches. Width, parentheses, equals 7.5 inches. A board. So we have to send like an image of said board. So we're gonna do this. That is not what I want to do. I'm gonna drag the image over. Check it. What? Copy image. Paste. Aha! I can crop it. That's exactly what we need right now. Not like that, you idiot. Wait, God, hold on, wait. Can I just have it in its original proportions? Sure, that'll work, okay. Um, okay. So there's our box. Alright, there's our oh so glorious box. Alright. Okay, so shut up. Now we get to include lines. Can I increase the thickness? Line weight 8. That works actually. We'll make it green for grass. Alright. Yeah, we want the line. I'm gonna like move it like there-ish. Actually, no, we need to make it like... Here, let's change the background first. Just make it like a black gradient so we can like... And then all the text gets turned from black to white. They get privilege. I'm never saying that again. Ignore all. Okay. Who is texting me? Jeez, Andy. Okay. So, let's put that there. Change all this to like green. Width? What color are we having width? Blue. Okay, we'll do like cauliflower or something. That's not actually that's a good color. W color. Okay. Going like that. Color cauliflower. Line weight 8. Okay. Aboard. Whatever this like dark gray is. We are going to... What are we doing? We're starting with a box. Dude, to be fair, it's supposed to be crooked. Because the box itself is crooked. Bro. I was low-key gonna go with orange. I think blue works better actually in this case, but anyways. Okay, maximize volume, keeping surface area constant. We're maximizing volume. Bold. Maximize. No, we don't need to. Because it currently has none. No. No. We shall give it some. Okay. List one of those specific situations. No. I don't like white. That's not racist. That's just based. And then we'll make this brighter. Okay. So there's our box. By the way, these two are really good toys. I don't like Bumblebee as much, but I think Optimus, I think is a great core class figure. Okay, now I gotta figure out how to do it.
And how big are
Okay, well, here's what we're doing, chat. We're gonna make the background absolutely black because we're gonna draw.
these?
We're drawing our thing. Bam, 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 bam. We have our little corners and a highlighter. Do 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 do. Okay, so let's get back to this problem. All right, Miss Kelly needs, or you know what? Mr. Kelly needs to make an open top box, store all his magic cards. He has a piece of cardboard that is 14 by 30 inches. To do this, Mr. Kelly cuts out squares of equal size from the four corners so the four sides can be bent upwards. What size should the squares be in order to create a box with the largest possible volume?
We don't know. So we're going to call it X by X. So all of these will be an X by X. Now, if we cut those out, you could then bend this up. You'd have to visualize this if you got the spatial understanding of what's going on here. A piece of paper, cut out the corners. Now you could fold this and bend it up, and you'd have a three-dimensional box that is open on top. Okay? So what we're doing now is, what else do we know about this? Oh, this whole thing here is 14 all the way across, and this whole thing here is 30 all the way.
All right, so we got that so far. All right, so we have, let's get the green back out. So we have 7.5 and 7.5, right? We have 10. 10. If we get smaller, we have X by X on every single one of these. Okay.
Way up and down for the cardboard. And what size should the squares be? So how big should X be in order to create a box with the largest possible volume? So
Okay.
we go largest. When something
So we're maximizing volume and keeping surface area constant. Okay.
is large, we're trying to optimize it. The large.
So the surface area then of this is just going to be 10 times 7.5, which that's okay. So the surface area, okay. So no, hold on, we want to make it thicker like that. So real quick, can I like get rid of these? Delete. Just I delete it, please. Wait. Yeah, okay, there we go. Okay. I need the select tool. Taking everything. Okay. So our box is up there. Alright. So we got that. And I know it's not going to save if I close out of the thing I got here. So what I'm going to do is I'm just going to screenshot it and then paste the picture once we're done. But we're not done yet, are we? No, we still got work to do. Okay. So surface area in this case is simply, I'm going to make it smaller and we're going to change the color. Is just length times width. Alright. And we need, that's too dark. Hold on, let's do that. We need volume, which is length times width times height. Go get some food.
Gist.
We're gonna be here for a while.
So what is volume equal? Volume equals length times width times height. And this is what we want to optimize, but we can only have one variable here. We have three.
You heard him. We only have one we can only have one variable, and yet we have three
variables in terms of three variables. So let's change it. What is the length?
So we could also write it this way, and we will go a little bit darker purple. So V equals, and we'll change colors again just because we'll go like this. So I go 10, 7.5 x. Alright? Or 10, 7.5, which equals 75 inches squared. Okay.
Length of this box. The length of the box goes from here to here. Well, if the whole distance is 30, we're going to take 30 and subtract what we cut out. We cut out an x here, and we cut out an x here. So we're cutting out 2x.
30 minus 2x. Wait, where's he going with this?
And then
I'm
the
curious.
width all the
Oh!
way across, it's going to be very similar. It's 14 minus the 2 x's that we cut out. So 2x. And then times it by the height. This is a little tricky. Some of you might not see it. What's the height of this box? Can you visualize? Fold this
It's just
thing
going to be
up.
x.
How high off the screen would this
Right.
be coming towards you? It would be a distance of x.
Yeah, okay, that's what I thought. Okay, so we did fumble a little bit, which is fine. So we have 10 minus x. I should have had like a touchpad. Wait, no, it'd be 10 minus 2x. Alright. Then 7.5 minus 2x. And then multiply it by x. Go grab some chocolate.
However high this is. So that is how, if you fold it up, that's the height of that side right there.
Okay.
All right, now let's clean this up just a little bit. If I FOIL this all out, multiply it, distribute, 30 times 14 is 420, and I know that because I have a calculator next to me, and
You know, that's a valid opinion, and I should get a calculator. By the way, chat, let me just say this right now. TI-84, if you need a calculator, just get one. Okay. So, we need to FOIL these out, and then we can just multiply it by x. So let's go do that. So we have 75. Okay, and then minus. So is that 20x and 15x? So that's 25x minus, or I guess plus in this case, 4x squared. Okay, times x. Which when we clean that up, that I don't like that parentheses. Okay, when we clean that up, that becomes 4x cubed. That was ugly. Hold on. 4x cubed. Alright, minus, what's this? 25x squared plus 75x. Okay.
I already did it. Minus 60x minus 28x plus 4x squared, and then times the x, and then one more
Yeah, because then that combines into 78. Yeah,
step.
okay.
We can go ahead and combine like terms and distribute the x all at the same time, and that'll give us our answer of this thing here. That's
Don't
a
even
cubic
worry
function.
about what schools are
This
doing.
is what we're trying to optimize. We're trying to optimize the volume, and so we
Okay. That's our golden equation. Let's get our darker purple back so we can write V 2 times. V equals V equals. And then we're going to grab a golden yellow and we're going to like highlight it. Just habushki. Alright.
would, again, next lesson we'll figure out how to do that, but it's just literally taking the derivative, setting it equal to 0, solving from there.
What? Wait, is that literally
Figure out
it?
how to do that, but it's just literally taking the derivative, setting it equal to 0, solving from there.
Oh my. Dude, if it wasn't that simple, oh my. Okay. So it's taking the derivative, setting it equal to 0, and solving from there. Here, can I like redo that highlight? Okay. Actually, can I end deriv this, maybe? dx. So what is this? 4x cubed minus 25x squared plus 75x. If x equals 0, what do I get? 75. 0.000004. I'm just going to take the derivative manually because I trust myself more than that. Okay. I'm going to label the steps when we get done. Okay. I'm actually just going to leave that slide. Okay. So, we're finished with this slide. Alright, so we can take this and we screenshot it. With, I guess, a little bit of white outline. It's like that. Because what happens when we get out, it goes. And it reappears. And there it is again. I'm like, make it proportional, please. Okay. 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 So there's all our glorious work. Saved. And now I'm going to grab the shape tool.
Oh, shit.
Shape arrows. Angle up there, move it. Yellow border, dark yellow fill. And then give me a text box just like right there. This is what we are optimizing. I like take, no, I just want all of, I want to like just there. There we go. Ew, it's white. Black. Okay, so we kind of got to do the same thing. So what I'm going to do is I'm going to screenshot this little bit right here. I probably didn't need to do that actually. 4x cubed, 25x squared, 75x, okay. So we're going to get our little drawing tool back up. Back to that purple. Okay. V equals 4x cubed minus 25 5x. Terrible 5, dude. 25x squared plus 75x. Okay. So this is our equation. We need to take the derivative of this. And I'm not doing it if like on a calculator. I'm just going to do it by hand because we have to show our work. So I'm going to show my work. And we're going to just use red just for simplicity's sake. Okay. So derivative of that is going to be 12x squared. So this is v prime. 12 squared. So this is what? Minus 50x. And then plus 75. Okay. So now that we got that, we now will take orange and set it equal. That was terrible. Set it equal to 0. It needs to be like more oval. There, that'll work. Okay. Okay. So now I just need to solve for x. So how do we want to do this? How does he do it? I'm curious.
And then we hard parts. Problem, weird. The other one's only tweet a dot on the ground is this, but is just next lesson. This is actually the hard part, setting up these equations. Don't stress about that yet. Zero solving from there. Figure out how to do that, but it's just literally taking the derivative, setting it equal to 0, solving from there.
I'm gonna do this on paper real quick. Okay. Okay. So v equals 4x cubed minus 25x squared plus 75x. You do v prime, that equals 12x squared minus 50x plus 75 Set all that equal to 0. What are we doing? We're going to do this. 12x squared minus 50x plus 75 equals 0. Where do we want to start? Hmm. Dude, I can't brain. I've been doing too many integrals. My mind's not on the right dimension right now. I need to find x. Let's ask ChatGPT. No, see, the problem is I have to show my work. Which means I'm going to look at something on my paper. Where is it? Where's that damn paper? Oh, it's right here.
Why did I think that was code?
It might be one day.
No.
Okay. X squared minus 260. I'm gonna do this on my. Okay, hold on, wait. It's 260x plus 1000 equals 0. And x equals 5. So how do I get x equals 5? I'm gonna try this. Actually, yeah, no, hold on. Pretty sure you could just square root the first bit, right? No, because then you end up with the square root of x. No, you wouldn't. Well, yeah, you would. Oh, we don't have to square all of it. We could just square the one bit, I think. Square. Nope, can't even do that because we get I. Okay, this is a problem. Where's... I don't know if we did an optimization problem on the test. Now, let me look. Hmm. Wait a minute. Oh, okay, no, we're fine. Okay. Well, let's go deep diving back into history. Basic integration, particle motion, analytical graphs, connections. Implicit differentiation. Actually, this might be what I want. Actually, I don't think it is. Riemann sums, antiderivatives. Is this what was? Was there an optimization problem here? I don't remember. Well, it wasn't there. There was. Okay, well, this helps. Okay, but there's only 2 terms there. Oh, no, that's a whole different thing. Okay. I need to stop looking before I lose my mind. Okay. Fine. Chat wins. Let's go use ChatGPT. Log in. Y'all can't see this. I have too much private information. Alright, chat can see now. Alright, message ChatGPT. Okay, so derivative of what is it? Okay, no, wait, hold on. We don't need the derivative. What is x in the equation 12x? What's the caret squared? 12x squared. You can send the image? Mm-hmm. Yes. Here. Need you to optimize a board with a length of 10 inches, a width of 7.5 inches to a box with the 7.5 inches. What would be the maximum volume of the board? I wonder if it would answer that. Yeah. Yeah. Calculate the derivative. Set it equal to 0, solve for x. On the fart. Um, Cause I don't know what that red text was. How do I get x equals 1.41? Derivative of v, and how would you solve for x when v prime equals 0? Mm-hmm. Do we have to use the quadratic formula, dude? We would. Okay, well, let's do it. So, now we have to use the quadratic formula. Okay. This makes me want to explode, dude. No, because we had a, like... Oh my god, I had AP pre-calc with, this teacher, Drefts. I love that guy. He made us take the derivative of the, quadratic formula, and it really irritated me. Okay. So... Yeah, okay. So... We're gonna make it green. Let's see. Text. A. Shrink it. B. That's not what I want. C. Okay. Okay, so now we're gonna solve it, and I'm just gonna do it by hand. So, negative 50 plus or minus square root of negative 50. Lord. Haha. Is it b squared? Okay, negative b plus or minus the square root of b squared minus 4ac over 2a. Okay. D squared minus 4, 12 plus... No, that we don't need a plus. 75 over 2, 12. Okay, we're getting somewhere. It's just negative b, okay. So this turns into just 50. Oh, this would probably be important, huh? Equals 0. Okay, anyways, back to reality. 50 plus or minus fudge. That's plus or minus square root. This is why we have calculators out, ladies and gentlemen, so we can do quick maths. Okay, negative 50 squared. That's, wow, okay. Negative 2,500. Okay. So, negative 4 times 12 times 75 minus 3,600. That seems differentiable. All over 24. Okay. So now we can take the square root of negative 2,500 minus 3,600. What do you mean non-real answer? Come on. I need this part. What the f is a discriminant? Yeah. What? I mean, that makes sense. We probably shouldn't be having to do all that. Okay, introduction. Okay, we want the solving one.
Hello, calculus kids. This is Mr. Bean, and today's really easy because we don't have to worry about anything with implicit equals 0. If that equals 0, then the calculator, I would practice doing this, so if you want to grab yours.
Oh, two towers. I'm sorry.
Is that really necessary?
Yeah.
No.
I want to solve for a particle. Oh, well. That's 3,600 divided. What's. Wait, hold on. Because it's negative 50 squared. Negative 50 squared. Negative 50 times negative 50. Wait! No! Hold on! Oh, that's a big eraser. Hold on. Chat, I've been doing this wrong the whole time. It's positive 2,500. Okay. 2,500 minus 3,600. There's negative 1,100 under there. So this is 50 plus or minus the square root of negative 1,100 over 24. Does that please something that has a square root? It's a non-real answer. How do I do this then?
Gavin.
Negative b plus or minus squared b squared for a c. I didn't do it wrong. Unless I messed up in the other one. But I don't think I did. Yeah. I have an example of this somewhere in here already. Okay, great. I'm dropping stuff. Okay. Okay, Can I, like, mute conversation? Okay. Maybe we don't even need to do the quadratic formula. Maybe we just solve it. So then it's how do we even go about doing that? So I could do this. Hold on. Okay. And divide off. You can divide off x both sides. Giving us who? Okay, so now we have 12x minus 50 equals 75 for x. If I divide x again, well, so wait, what's this then? 75 over x divided by x. It would be x squared?
Is that necessary? Let's act like you're flirting with each other.
Oh, so it would. Actually, that might help.
So it's weird when I don't get along with my siblings, but it's weird when I do.
So
Well, depends on how you're
12
how
minus
well you're getting along. You're not supposed to get
50
along well with any of
equals.
them.
Okay, hold on, wait.
I'm
I
just
gotta like
kidding.
write in the steps.
Why do you have two glasses, Dad?
Because I'm double blinded.
Dad, you look like you're gonna go to like see a movie in 3D.
I'm like
Ben,
double
throw away your
blinded
trash.
You're blinded.
I'm
by the
assume.
light.
You're blinded by my light. Right?
Okay.
You're just the light of your
Wrapped
favorite
up like
daughter.
a deuce. Another roller in the night.
Divide by x.
Blinded by the light.
This becomes 12
You heard that song before?
minus 50 equals.
Blinded by the light. Wrapped up
Squared.
like a deuce. Another roller in the night. Blinded by the light.
Yeah, because we were able to pull an x from both of them. From both these terms. After putting negative 75 on that side. So now we can do that, so minus 50, so we have negative 38. Yeah. So but to Whoville with this color. So this becomes negative 38 equals 5 over x squared. Oh, but it's negative in front of all of it.
There we go.
So I'm going to take negative 75 over x squared divided by negative 1. Let's change the whole thing into positive. Okay, so would. Good. So that's a start. So okay, then I know what I'm doing. So divide by negative 1, divide by negative 1, come up here, 38, that's a terrible 8, nope, 38 equals 75 over x squared, multiply both sides by x squared, wait, no, hold on, different color to show step, okay, x squared show it cancels. Off in red. No, not like that. Like this. I would like it thicker, so. Sure, that'll work okay. Back to that green, go back here. Okay. We have 38x squared equals 75. Does 75
Shush. You want some food? You want your dog food?
square root into anything? Hold on. So, square root of 75. We're going into decimals anyways. I don't know why I'm. Okay, it's fine. So, back to. We'll use purple for this. Square root both sides. So now I have 38x equals 75. And at long last, divide. I want to go back to blue. We're going to pink again. Divide by 38. I had a color picker tool. Nice. There, okay. What I'm doing is wrong. We just wasted a long time on this.
Dad, 3 months.
Brayden, you better do your dishes before you do anything else. That's all
We're
I ask.
going to sob our eyes out now.
Chill the fuck out.
3 days from now, 3 months from now, we get another Hunger Games book.
You get another what?
3 months from now, we get another Hunger Games book. I am ecstatic.
Wait, can I just do this then? Hold on, wait. I have
Sunrise on the Reaping.
12x squared plus
Sunrise on the Reaping. You know Haymitch?
75 equals
Drum sound?
50x.
The mentor?
The mentor?
The mentor?
Uh-uh. Hey, Mitch.
Captain? You have seen the movies, right?
What?
Of Hunger Games?
Oh, yeah, yeah, yeah.
Yeah.
I
This
don't.
book is
What's
about
his
like
name?
this game. Haymitch.
Hey, Mitch.
I don't
This
think I
book is about
can.
his game.
I
Oh,
subtract.
the old guy?
Yeah, yeah, yeah. About his
Oh,
game.
no, the drunk guy.
Mhm.
What's his name?
Haymitch.
Yeah, but Woody Harrelson is the actor in the movie who plays Haymitch.
We get to see his book. We get to see his game.
He's you mean you get to read about it?
Mhm.
You don't get to see shit
We
up
well,
close.
we'll get to we get the movie soon. We get the movie the year after, 2026.
Oh yeah. So they're still writing the books? They still, or are they already written, or what's the deal?
I don't know. There's
They're still
already.
writing them, obviously, if they're gonna make
Hmm.
more movies. Otherwise, they would have just incorporated it all into one fucking series, one mini series, or something.
I don't mind. I love these. I love these books.
They're Hunger Games. They're good.
Those books are great. I've read all four that are out.
Alright, I'm gonna figure this out on my own.
Okay, part 1 and 2. Because I thought like this.
This is just torture.